Okay, I want you to consider something. Consider the square root of negative 3 squared. So the square root of negative 3 squared. Notice how the negative 3 is in parentheses. Negative 3 squared is negative 3 times negative 3, which is positive 9, right? Which equals 9 inside the square root. Well, we know the positive square root is 3. The positive square root of 9 is 3. But these two things should match up, and they don't. Well, part of that is because we didn't put the negative sign in front of the root. But the other thing is we've got this limitation here. Because we always have a root and we're assuming it's going to give us the positive version, sometimes the negative inputs give us a problem. Where does this get to be an issue for us? Well, if I have the square root of x squared, say, well, I really know it's just going to be x because the square root is the same as having the 1/2 as the exponent. We've talked about that before, I believe. And the idea there comes out to be 1. We're good to go. The problem is if I plug in a negative 3, I don't always get the same answer. If I plug in positive 3, x equals positive 3, I get 3 squared equals 3. And yeah, the square root of 9 is 3. If I plug in x equals negative 3, I get square root of negative 9, of 9 equals positive 3. But these two don't match, and they should match. So there's a problem. The way we fix that problem is anytime you're taking the square root of an even power. So square root of an even power. And the result is an odd power. Absolute value. So here we're taking the square root of x squared, so we're taking the square root of an even power, and the result is an odd power. Remember, if we don't have an exponent, it's 1. I'm going to put this whole thing in absolute value. So the square root of x to the 4th, it's just x squared. You cut the exponent in half, no problem. Square root of um, x to the 5th, well, they're not divisible there, so that doesn't really work, but I can see it's square root of x to the 4th times x, so I just have x squared times root x, no absolute value. The square root of x to the 6th, I'm taking the square root, that power is even, and when I divide it in half, I get x cubed, which is odd, so I'm going to put it in absolute value. So that's what we're going to be doing here. Um, it's just kind of one of those things. It's a little weird, but it's what we have to do to take care of the details of the negatives, which you know from math always give us problems. All right, example 3, simplify a square root with variables. So I'm going to I like to break this apart to things I can take the square root of. 90, well, what is that? That's 2 times 45. No, nothing there. Oh, 45 is 9 times 5, isn't it? Oh, wait. 90 is 9 times 10. And 9 is a perfect square. Haha. Okay, there we go. I can take the square root of x squared. Next one. Notice I just broke apart the x cubed using the uh, power over product rule. Same thing, well, y to the 4th, I can take the square root of that. I just divide the 4 by 2. Z to the 4th and z. to the 1. Okay, so I could take the square root of 9, it's 3. I can just take the square root of 2, the square root of x squared, it's x, but the result is 1, is an odd power, so I make it absolute value. So I'm going to make a little mark here. I've taken care of this guy, taken care of that guy. The square root of y to the 4th is y squared, and the result happens to be even, so I don't need absolute value. So I've taken care of that term. Z to the 4th, that's going to give me z squared, or even resulting power, so nothing happens with it. And then I'm left with the z to the 1. So what's left inside of the square root? I have 10 and x and z. So there's a simplified form.